Okay, so in this problem, we're going to find IA, the
IA.
current through the current in this current source. So to find this current, we're going to have to use Ohm's law, V equals IR, and KCL.
What's that, Mark?
KCL, I'm glad you asked. KCL means that at any node, the current going into the node equals the current going out of the node. So in this, to get started on this circuit, we can use Ohm's law to find the voltage in this resistor because we have a value for resistance and a value for the current. So we'll call this V0. So V0 is going to equal 2K times 2 milliamps equals 4 volts. Now, since we know V0 has 4 volts, and this is a 6 volt source, we know that the 6 volt source will bring us up to 10 volts over here.
Is that like a supernode?
Yeah, that's what a supernode is. It's when two nodes are connected by a voltage source, you can just add it up, bring it up. So, and the same thing we have is over here. So we can go from 10 to 16 volts up here. Oh, that's a 6.
How do you know it goes up and not down?
We know it goes up because the polarity on the voltage source. The negative, this is the negative, the lower side, this is the positive, the higher side. So this is going to be 60 and that's 10.
Gotcha.
So now, using Ohm's law, we can find the current through this branch, I1. Now I1, we can find I1 because we know the voltage across this resistor, 10 volts to 0 volts, divided by 1 kilo ohm, which is 10 milliamps. So since we know that this is 10 milliamps going this way, and I0 is 2 milliamps going in, so that's 10 milliamps going in plus 2 milliamps going in means 12 milliamps going out.
Math is fun.
Oops, whatever. Okay, 12 milliamps going this way. So since we know there's 12 milliamps going this way, and through a 1K resistor, we know that this is going to be 12 volts. But there's something wrong about this. Miles, what's wrong with this situation?
I think current flows from high to low.
Right, so if this is 0 volts, and this is 12 volts, and 0 is the higher one, this needs to be negative 12. So it goes from 0 down to negative 12 because of the direction of the current.
Oh.
So we can use that principle once more. So we skipped over I2, so we're just going to put I2 right here. Well, we'll call this I3. So this is I3. Now, I3 we know flows in this direction because once again, current flows from a higher potential to a lower potential. We know this is 16 volts, and this is negative 12 volts. And
So what's the voltage drop across that 2K?
so the voltage drop across the 2K is the potential difference across the resistor. So the potential difference across the resistor is going to be 16 volts minus negative 12 volts. So we're going to go 16 minus negative 12. And this is all divided by 2K. So that would be 28 divided by 2 is 14 volts. So, oops, did I say volts? Milliamps. So this is 14 milliamps going in. So now we have a current going in, a current going in, and a current going in. So
You can find IA.
we can find IA by using KCL with this equation here. So IA plus I3 plus 12 milliamps equals 0, or IA equals
You gotta put in I3, bro.
negative I3, which is 14, minus 12 equals negative 26 milliamps.
And that's our answer?
And that's our answer for IA. Thanks for watching, folks.